So hello and welcome back. So in this video we want to do the continuation of basically factorization that we were doing in the previous video, and we have two more examples to go, and we could probably pick a few more to work on. So let's say that you want to factorize y squared minus 5y plus 6. So for example, let's say p of y is equal to y squared minus 5y plus 6. And you want to factorize it using, factorize using the factor theorem. The factor theorem. Okay. So basically using the factor theorem, if you want to factorize this, what you need to do is that you can use this polynomial, which is y squared minus 5y plus 6. You can write it as basically the product of two polynomials, and these two polynomials are going to be, for example, something like y minus a and y minus b, and then the zeros of the polynomial are going to be a and b, zeros being a and b. Okay, so if your zeros are a and b, then the factors become y minus a and y minus b. And the reason for that is that when you get your factors like this, then if you basically set your factors to 0, y minus a, for example, is equal to 0, then y is equal to positive a. And that was basically the 0 that you had here. Or when you have this factor over here, y minus b is equal to 0, then y is going to be equal to b, which is basically the 0 that you had over here. Okay, so you need to be careful about how you think about your zeros and how you basically write your factors. It's going to have always this kind of relationship, and meaning that in algebra it's going to fit together this way. So then once you have this thing figured out, so you can then write this as y minus a, y minus b, and here you can write, for example, a and b being the zeros of the polynomial p of y, okay. So once you basically do this, now you know that you see that your polynomial is basically in the form y minus a times y minus b, and you know that basically this 6 over here is actually the product of the two factors, meaning that, the product of the two zeros, meaning that a times b is equal to this constant over here, which is equal to 6, right? So, and we talked about this in the previous example, I suppose. So a times b is equal to 6 here, meaning that the product of the two zeros is equal to 6. Now, since the product of the two zeros is equal to 6, you can factorize 6 as, for example, 1 times 6 and, for example, 2 times 3. So the factors of, or basically all the factors of 6 are 1, 2, 3, and 6. That means that you can write 6 as 6. The factors are basically 1, 2, 3, and 6. Okay, so now you need to check each of these factors, and of course you know that since the product of the factors is positive, then you can have basically a positive number times a positive number, that gives you a positive number, and a negative number times a negative number is going to give you a negative number. That means that basically you should actually take the basically positive and negative for the different choices of A and B. So the possible choices of A and B would be basically plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6 basically. And then once you have that also figured out, you know that based on the factor theorem, if y minus a is a factor of this polynomial, then P of A has to be equal to 0. So that means that now I calculate P of each of these numbers and see whichever one is P of whichever number is equal to 0, then that means that number is actually a 0 of this polynomial. So then P of, for example, 1 is equal to, of course, it's going to be plus or minus 1, plus or minus 2, and so on and so forth. So P of 1, for example, would be 1 squared minus 5 times 1 plus a 6, and that's equal to 1 minus 5 plus 6, and that's equal to 7 minus 5, which is equal to 2. So this is not the right number. Now if you have P of negative 1, for example, what you would have is basically so negative 1 whole squared minus 5 times negative 1 plus a 6, and then you would have 1 plus 5 plus 6, that is equal to 12. So that's not the right number either. So let's go for example, the number 2. Now I start with positive 2, so P of 2 is equal to basically 2 squared minus 5 times 2 plus a 6, which is equal to 4 minus 10 plus 6, which is equal to 4 plus 6 is equal to 10. 10 minus 10 is equal to 0. So that's one of your numbers. Number 2, basically positive 2 is one of your numbers. And then the other number that you can try is probably, now of course probably you're not going to have the same 2 over here. So I'm going to go with, for example, a 3 over here. So for example, P of 3 is equal to 3 squared minus 5 times 3 plus a 6, and that's equal to 9 minus 15 plus 6, and that's equal to 15 minus 15, which is equal to 0. So the other number is positive 3. So now I know that the 2 zeros of my polynomial are basically positive 2 and positive 3. Positive 2 and positive 3. So since the 2 zeros, these are the 2 zeros of P of y. Therefore I can write P of y as y squared minus 5y plus 6, and then I can write it as y minus 8 times y minus b. So that would be y minus 2 times y minus 3. And that's basically how you could solve this problem. Now about basically third degree or third degree polynomials or cubic polynomials, it's going to be a little bit, I mean it's not really more complicated than in any way, but splitting the middle term is not going to be basically possible, because the polynomial will have more parts, and then you cannot actually split and most probably you have, let me see, ax cubed plus bx squared plus cx plus d, and moreover there is really no middle term in a cubic polynomial. There you have 4 terms, and then there is really no middle term here, unless you made some arrangements there, but it's just simply at least not in standard mathematics, basically. So so then what you need to do here is that you need to start with you need to start with the last term in your polynomial, which is basically the constant term. If you have, basically, if your polynomial is in the form ax cubed plus bx squared plus cx plus d, okay? If you have your polynomial in this form, basically this last term is equal to the is actually equal to the product of the 3 factors multiplied together. Okay, so what that means is that basically you have and moreover, if you actually try to solve this, basically try to actually find the meaning that you could, for example, go for example, E, F, and G. Let's say that the zeros are, for example, E, F, and G. Let's say that you have 3 zeros here, and then your factors would be, for example, x minus E and x minus F, and, for example, x minus G. Okay, and if you actually multiply these together, the last term, or the constant term, is going to be equal to negative EFG. That means that this constant term actually would correspond to, it would be equal to negative EFG. Okay? But that's not the problem, because you don't have to go all the way through with basically with the factor theorem. You just find if you can manage to find one of the zeros over there, and then you can basically reduce your polynomial to a second degree polynomial, and then you can use, for example, some better method, like, for example, splitting the middle term, and then you can factorize the whole thing, meaning that basically what you can do here is that basically let's say that you have a polynomial x cubed, for example, minus 23x squared plus 142x plus 142x minus 120. Okay, and now since basically your last term is negative 120, negative 120 would correspond to the negative of the 3 factors multiplied together, meaning that, for example, E, F, and G. And what that means is that then 120 is equal to EFG. So now you know that this and EFG basically being the zeros of this polynomial. Okay, so what that means is that you can factorize 120, and then, but of course not prime factorize. You need to get all the possible factors of 120, which is a little bit actually, which is a little bit tricky. Because you might actually make mistakes over there, but we will go over that together. So now basically 120, if you want to prime factorize it, that would be 1 times 120. That would be 2 times 60. That would be 2 times 30. That would be 2 times 15. And that would be 3 times 5. Okay, so this is basically the prime factorization of 120. And now, of course, you can say that the prime factorization of 120, you can write it as, for example, 2 cubed times 3 times 5. That's the prime factorization of 20. But since you are looking for all the possible factors of 120, you need to consider all the different combinations of these numbers. And how you can do that is that actually I had found a very good way to just do that, but unfortunately I forgot that. I mean, by accident, really, I found a very good way to do just that, find all the possible factors of a number, but I forgot that. So, but I think what you can do is that, meaning that, of course, you know that one of the factors is 1. This is easy. One of the factors is 2. One of the factors is 3. So I'm writing all the unique factors now. One of the factors is 5. One of the factors would be, for example, 15, 30, 60, and 120. 15, 30, 60, and 120. These are all the basically numbers that you can see. But there are some other numbers that you can get by basically multiplying these numbers together. For example, you would not, for example, multiply 5 and 3 because you have already written 15 over here. So I think what you can do is that, of course, I have written a single 2, so I don't have to write a single 2, but 2 times 2 is equal to 4. So 4 is another factor. Or 2 times 2 times 2 is equal to 8. So 8 is another factor. And moreover, then you can get to the next prime factor that you have, and then multiply it by all the possible different ways that you can multiply your 3 by these 2's, basically. So 2 times 3, for example, is equal to 6. 4 times 3 is equal to 12. And 8 times 3 is equal to 24. So these are all the again factors of 120. And then you need to do the same thing with 5 as well. So meaning that 2 times 5 is equal to 10, and 4 times 5 is equal to 20, and 8 times 5 is equal to 40. I think these are all the basically factors of 120, if I'm not wrong. So 1, 2, 3, 4, 5, 6, 8, 10. 1, 2, 3, 4, 5, 6, 8, 10. 12, 15, 20. 12, 15, 20. And 24, 30. 30 and 60. So of course 120 you don't have to write it, right? 120 I don't have to write it, but then here the only thing that remains that I haven't taken care of is um, 120 is actually divisible by 40. It is divisible by 40, right? Yes, it is actually a factor of 120, but it's not in the text that I have, so but it's actually not wrong, it's right. So the way that I actually did the factorization and the way that I wrote these factors over here was actually right. So I think I got it back somehow. Okay, so your factors are basically these numbers over here. So I rewrite them over here as 1, 2, 3, 5 in the same order. So 120, all the factors would be 1, 2, 3, 5, 15, 30, 60, 120, 4, 8, 6, 12, 24, 10, 20, and 40. Okay, and even if you can find one of these numbers that works for you, then you can forget about the rest of them. So you need to actually kind of start with one of these numbers. For example, if I call this for example p of x is equal to x cubed minus 23x squared plus 142x minus 20. And of course you need to let me see. Yeah, basically you need to consider positive and negative of all of these numbers. Okay, so of course you need to consider positive and negative of all of these numbers. So so then, for example, p of 1 would be equal to 1 cubed, which is equal to 1 minus 3 times 23 times 1 squared, so minus 23, and 142 times 1 is equal to positive 142 minus 120, and that would be equal to 143, 142. That's actually equal to 0. It's actually equal to 0 because 120 plus 23 would be equal to 143, and 143, that's a negative 143, plus 1, that would be negative 142, plus 142 is equal to 0. So this actually works. So you don't need to worry about the rest of the numbers really. This one works. So that means that 1 is a 0 of p of x. Okay, so that means that 1 is a 0 of p of x. So that means that you can write for example, you can write your p of x, which is this thing over this polynomial over here, as some polynomial as some polynomial times and the factor related to this 0 would be equal to x minus 1. So then I can write p of x as some polynomial g of x, for example, times x minus 1, and I know that x minus 1 is a factor of p of x, for some polynomial, for example, g of x. Okay, so now how can you actually get to g of x? Well, how can you find what g of x is? So So now let me see, there is actually different ways you can divide and you can do different things, but let me see what there is here. Okay, so now in order to figure out what your g of x is, what you can do is that you can divide, meaning that you know that this polynomial over here, which is basically your p of x, so I can rewrite this equation as x cubed minus 23x squared plus 142x minus 120 is the same thing as x minus 1 times g of x times g of x. Okay, so that means that g of x is the same thing as this whole polynomial, x cubed minus 23x squared plus 142x minus 120 divided by x minus 1. Okay, so we can do this division. Let's find out what the polynomial is. So you have x cubed minus 23x squared plus 142x minus 120, and you divide that by x minus 1, and what you will get is, so if you divide x cubed by x, you'll get an x squared, and x squared times x is equal to x cubed, and that's minus x squared, and then negative positive, so these two will cancel out, and then you'll have negative 23x squared plus x squared, which is negative 22x squared plus 142x. Okay, and then negative 22x squared divided by x is equal to negative 22x. So negative 22x times x is equal to negative 22x squared. And that's a positive 22x. Then what you will do is positive, negative, and then add these together. What you will have is basically 142x minus 22x, which is equal to 120, actually 142. I don't want to make a mistake here. So 0 to 120, so that's 120x, and then minus 120. So now 120x divided by x is equal to actually 120 plus 120. So that's 120x and minus 120. Positive, negative, cancel out 0. And of course, you should expect to have to get a 0 remainder because you knew that x minus 1 was actually a factor of this polynomial here, right? So then g of x is equal to this polynomial here, x squared minus 22x plus 120. Okay, now I erase all of this, and now you can, so now what you know is that your p of x, which is the polynomial you started with, is x squared minus 22x plus 120 times x minus 1. Okay, so now you need to factorize this part, and this part is actually what you need to do. You're actually looking for two numbers whose basically you're looking for two numbers, let's say a and b, such that a times b is equal to 120 times 1, which is equal to 120, and a plus b is equal to negative 22. Is equal to negative 22. So the numbers are, it's a little bit tricky. So you can use the factorization of 120 and negative 22. 120 and negative 22. So you can go for example, I don't know, I think we'll need to factorize this 120 one more time. Okay, so I write this. So you have 120. So you have, let me see if you can get it this way. 2 times 60, 2 times 30, and 2 times 15, 3 times 5. So you can write 120 as, for example, 2 times 60, which is not going to help me, or 4 times 30, which is the two numbers that I have are 120 and negative 22. 120 and negative 22. This is the product. This is the sum. And so you see the product is actually positive, the sum is negative. So you could actually take both the numbers. You could take two numbers, for example, A and B, both of them being negative, okay? And then negative plus negative is equal to some negative number, and when you add them together, you'll get a positive 120. So if you find two numbers, for example, 15 times 2, no, 5 times, for example, I don't know, 5 times 24, 5 and 24, that's going to give me 29. That's 15 times 8, that's going to give me 20, it's going to give me 23. Is it? Okay, so for example, now I actually did see the two numbers. The two numbers happen to be 12 and 10. And 12 and 10 is actually, the sum of them is going to be equal to 22. And I didn't actually mean to see the numbers, but I did see the numbers, and actually the fun is over. So we'll have to get the numbers and run with them. So, but I didn't really want to do that. I was just looking over and I saw the numbers. So that's basically your number. So negative 12 times negative 10 is equal to positive 120, and then the sum of them is negative 22, negative 12 and negative 10. So then I come down here and write this as, so let's see. If you have x squared minus 22x plus 20, I write it as, so x squared minus 22x plus 120, I write it as x squared 10 and 12 it was, right? Negative 10x, negative 12x, negative 22x plus 120. And then you can take, for example, these two together, take an x out, x minus 10, and take these two together, take a negative 12 out, and then you'll get x minus 10. So then you would have x minus 12 times x minus 10. Okay. So then this polynomial is going to be equal to, so then this polynomial over here is going to be equal to p of x is equal to the factorized version of this polynomial, which is this polynomial, x minus 12 times x minus 10 times x minus 1. Okay, So that's basically what we were looking for. It's not always really easy or straightforward, but of course mathematics is not supposed to be, I mean, by nature mathematics is not supposed to be easy. But there is, I mean, there is actually, it's actually fun. So, so now we have some exercises here, and we will go through a couple of exercises as well, because this thing over here needs a little bit of practice. So in the next video we will do a couple of exercises, probably, I don't know, an hour or so, and then we will see where that takes us. Alright, I'll see you in the next video. Thank you.